Hello everyone, welcome to this problem 2416 sum of prefix score of strings. So basically we receive as input an array of words and we are supposed to compute the score of each word, and the score of a word has been defined and as as the sum of all of the prefix string of the word. What does that mean? That means if I receive as input ABC, I'm gonna see how many string do I have in this array having a prefix of A. In this case, I have this string and this string, that is 2. Now moving to how many string do I have in this input that having a substring of AB. I have this and this. This is also 2 plus the previous 2 are, that is 2. And then how many string do I have in this input having a substring, having a prefix of ABC? Only this one, that is 1. So 1 plus 1 plus 2 plus 2, which is 5. So basically this is how you're supposed to compute the sum of the you're supposed to compute the score of an element. So now that being said, how do we approach this? So basically one thing you can do is that you can loop through your input, and for each of the element you count the number of occurrence. What do I mean by count the number of occurrence? That means you create a map that is going to increment the appearance of a given element, and after that you are going to reloop through your input, and for each of the element you take again the prefixes, and then now you count the occurrence since you already had a map previously with those elements. That is actually a straightforward implementation. Let us implement that and see what it will give. So we are just going to have a map of string int. I will call it MP. It's not the best name for that, but yeah, let's go with that. And I'm gonna loop for string s of word, and for each of the string what I'm doing is that I'm gonna loop. I'm moving from s dot size I is greater than 0, I plus plus, you understand why. So what I'm doing is that I'm looping through each of the word, and for each of the word I'm looping from the last index till the first index, because when I'll be here I want to compute the substring starting at the beginning till the index I and increment that to my map. So what will it give? So it will give something like this. I can do mp of s dot substring of 0 I plus plus. So what is happening here is that I'm creating the substring starting at position 0 to I, and I'm putting that into my map. So when it will come here, it will take this, it will put ABC at 1. It will now go, it will put AB at 1, and it will put A at 1 after iterating through this first one. When it will come here, it will put AB at 2 because we already had AB previously, and now he will put A at 2 because we were already having an A previously. So this is what this is doing. So basically this is actually, I would say, this is actually creating count, right? So now after this, the next thing I need to do is to reloop through my input, and now I should count the number of occurrences. So I can reuse this. It's almost the same. So I will have my input here. I will say vector of int. I'll have result. I don't even need this comment. It's not that useful. And so yeah, what I will do is that I will have an ans here, which is actually 0, and this is actually an int. And now when looping, so I'm just going to say ans will be plus equal to this guy, and then yeah, I'll just say result.pushback of ans, and yeah, at the end of my loop I need to return the result. So let us run and see. So we have a time limit. Why do we have a time limit? Okay, because we are incrementing where we should decrement our counter. Perfect. So it's working, but this is not actually the solution for this problem. Let us submit. You are going to find yourself with time limit. So if I submit this, despite performing really good on small input, we are going to see that it's going to not be able to solve some of those input out there. So now the idea will be to change the approach of counting the element. Let me share with you what I'm saying. Let's say I have this ABC. My idea will be to avoid creating substring whenever I'm moving. So let us take ABC for instance. What I will do is that the idea will say, okay, I have A. This is the initial of my tree. First thing, my next of my data structure should be able to handle 26 element. Next thing is that to compute an element, let us take this one. I'm going to take this as example to understand. So I'm going to take the input ABC. Let us go with the input ABC. If I'm going with A, B, and C, what I will do is that, okay, I'm starting at the beginning. Do I have at the beginning an A? No, I don't have. So what I will do is that I will create the node A, and I will put the value of the node as 1. I will increment the value at that position, and then I will move my pointer to that node. Okay, so after this, I'm here and I'm here. So I will say, do I have at this position a node B? No, I don't have. So I will create the node B, and then I increment the value at that position, which is 1. So that means initially 0. Do I have a node C? No, I don't have. So I will create a node C, and then I'll put the value at 1. So after iterating through the first word, this is what my map will look like. So now let us take the second one, is AB. So I'm now taking AB. Let me take here AB. When I want to insert a new word, I'm still starting at the beginning. Do I have a node starting at position A? Yes. So I'm not having to have 1 anymore. I'm going to increment it to put it as 2. Do I have, and then I move, I'm here. As from here, do I have a node starting? Do I have a node with B because I'm at B? Yes, I do have. So this one is going to be erased. This one is going to be 2. Why even do I increment every time I'm moving? I'm incrementing it because all of the node I'm seeing while moving can be the end of a given prefix sum. So this is the end of the prefix sum starting at 1 and ending at 1. This is the end of the prefix sum starting at 1 and ending at 2. So that is why while looping, each of the occurrence you are seeing is a valid end of a prefix sum. So you can just increment the value, and you are sure that you will be able to have the proper answer at the end. So if we do the same with BC, so with BC, it will behave a little bit different, because you are going to see we are starting here at this position. Do I have a next which is a B? No, I don't have. So I will create a B, and then after creating the B, I'm going to give the B the value 1. Do I have a C after this? No, I don't have. So I'm going to create a C here, and then the value here will be 1. And then after this, I'm taking now the last one, which is a B. So at this position, do I have a B? Yes, I do have a B. So I'm just changing the value into 2. So at the end, this is what my input will look like. My tree will look like. And then when I have this, so now the next thing will be to compute now the sum. And to compute the sum, what will happen is that you're just going to say, okay, for the word ABC, you are just going to sum all of the elements from the beginning to the end. That is why you are going to have 2 plus 2 plus 1, which is 5 for the first one. Now for the word AB, we are going to compute A plus B, which is 2 plus 2, 4. And for the word BC, 2 plus 1, 3. 2 plus 1, 3. And for the B is 2. Why? Because B is actually 2. So that is how we are going to compute this. Now that being said, how do we implement this? So we are going to use almost the same thing we have here, just that we will need to first have our, our input, our data structure. That's we are going to call a struct. Actually, we used to call that a try, or try note if you want. And like we said, each of the element of our try is actually another try. So each of the elements is a try, and then the try will be actually need to be able to handle 26 possibility, and then also a count. So you're going to have a count, which is an int, which is actually equal to 0 initially. We need this one here, and since it's an instruction, we need this one. So now that we have this, at the beginning of our operation, we don't need this map anymore, but we need to have like a root, which is a try node, which is, we are going to call it root, like this. And then now our process of counting, this is the process of actually inserting. So our process of creating value will be a little bit different. We are going to loop through all of the elements, which is nice. And for each of the elements, we are not going to do the substring anymore, but we are going to loop like for chassis of S. And then before doing that, one thing interesting is that we said whenever we want to insert a word, we are starting back at the beginning. So we need to have another element, another variable here that we are going to say maybe current, that is going to take root, and it's going to take the reference of the root. We can just type it auto here. And now for each of the element, what we are going to do is that we said if we don't have the current dot next of C minus A, then we are going to insert it here. But at the end, we are going to increment that guy, C minus A. We are going to increment, that means the count, and then after this you are going to say the current is taken. Now the current dot next of C minus A. See, I hope this is actually a little bit clear for you. So if you don't have, we create a new node. So the new node is actually saying okay, dot next of C minus A is going to take a new try node. This is actually creating. So from here, we are able to actually performing a proper count of the element. Now after this, I'm just copying and pasting here. We now need to count the number of occurrences. So for the count, it's going to be almost the same as what we did here, just that when looping, you don't need to do this anymore. You just need to count. You just need to have like, oh, I don't have the answer anymore. You need to have like int ans here, and you don't need to have any condition. You just need to have ans plus equal to yes, and then you move to the next one. Let us run and see what it gives. So I have an error somewhere. Okay. Oh, okay, nice. We have a wrong answer. What do we have? Empty. It is written an empty because I'm not actually pushing my answer. So I should have something like result of push back off answer here. Okay, So I still have a wrong answer. This is actually messing up with things. So this we should initialize as 0 whenever we are starting. Okay, perfect. Okay, so this is actually performing pretty well. So this was my approach of solving this. I hope you enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new challenge. Ciao.